Hello students, I am Madhuri, your maths teacher. Today we will learn grade 9 maths CBSE syllabus chapter 2 polynomials, and we will learn what are algebraic expression and what are polynomials. Then we will learn the polynomials in one variable. Also we will solve exercise 2.1. What are algebraic expressions? Algebraic expressions are combination of numbers 1, 2, 3, 4, etc. are numbers. Variables A, B, C, D, E, F, G, etc. are variables. And signs of basic mathematical operation, that means signs of addition, subtraction, multiplication and division. So algebraic expressions are combinations of numbers, variables and signs of basic mathematical operations. Example 3x. 3x, the number 3 and variable x, and signs of mathematical operation is into. 3x means 3 into x. Next algebraic expression is 2x plus 4y minus 9. Here 2, 4 and 9 are numbers. X and y are variables. Into, addition and subtraction are mathematical operations. Next one, 4x raised to 2 plus 1. Here numbers are 4 and 1, variable only x. And here the power of the variable is 2. Mathematical operation is into and addition. Here negative 3 x raised to 3y plus y raised to 2z. Here the numbers are negative 3 and 1. Variables are x, y and z. Mathematical operations are into and addition. Next, how do you know if an expression is a polynomial? You learn about algebraic expressions. So now, how do you know that an expression is a polynomial? So for an expression to be a polynomial, it must contain no square root of variables. So square root should not be there. Square root of variables should not be there in the polynomial. Then no fractional or negative powers on the variables. So here power of the variables should not be negative or fractional. No fractional or negative powers on the variables. And no variables in the denominator of any fraction. Should not be x divided by y. No variable in the denominators of any fraction. So a polynomial have no square roots of variables, no fractional or negative powers on the variables, and no variables in the denominators of any fractions. All polynomials are algebraic expressions, but all algebraic expressions are not polynomials. Now, the degree of a polynomial is the highest degree of its monomials. So, the degree of the polynomial 3x raised to 7 minus 4x raised to 6 plus x plus 9 is 7. Here, the degree of the term variable x is 7, here variable x is 6, here x is 1, here 9. 9 means 9x raised to 0. So 0. So here the highest power of the variable is 7. So 7 is the degree of the polynomial. Second one, the degree of the polynomial 5y raised to 6 minus 4y squared minus 6 is 6. Why here the power of the variable is 6, here power is 2, here power is 0. The highest power is 6. So the degree of the polynomial is 6. The degree of a non-zero constant polynomial is 0. 6 is a non-zero constant polynomial. 6 is equal to 6x raised to 0. X raised to 0 means 1. A variable raised to 0 is equal to, any number raised to 0 is equal to 1. So 6 into 1 is 6. So the degree of a non-zero constant polynomial is 0. The degree of a non-zero constant polynomial is 0. Now find the degree of each of the polynomials given below. First one, x raised to 5 minus x raised to 4 plus 3. Here the highest power of the variable x is 5. This is 5, this is 4 and here 0. So the highest power is 5. So the degree of the polynomial is 5. Now next one, 2 minus y raised to 2 minus y raised to 3 plus 2y raised to 8. The highest power of the variable is here 8. So 0, 2, 3 and 8. The highest power is 8. So the degree of the polynomial is 8. Now 2. The only term here is 2, which can be written as 2x raised to 0. So the exponent of x is 0. The power of x is 0. So therefore, the degree of the polynomial is 0. Next, polynomial classification. Types of polynomial on the basis of number of terms in the polynomial and on the basis of degree of the polynomial. On the basis of number of terms. If the polynomial has one term, it is called a monomial. Here, example 5x, only one term. If the polynomial has two terms, it is a binomial, 6x plus 4, two terms. Trinomial. If the polynomial has three terms, it is a trinomial. Here x squared is one term, 5x is another term and 9 is another term. Next one, on the basis of degree of the polynomial. So first one, linear polynomial. If the polynomial has degree 1, here highest power of the variable is 1. So it is a 5x plus 1 is a linear polynomial. Second one, quadratic. If the polynomial has degree 2, here the highest power of the variable is 2. 2, 1 and 0. So 2 is the highest power of the variable. So such polynomial is called quadratic polynomial. Then cubic polynomial. If the polynomial has degree 3, here the highest power of the variable is 3. So it is a cubic polynomial. Then if the polynomial has degree 4, it is a biquadratic polynomial. See here highest power of the variable is 4. 4, 3 and 0. So 4 is the highest power. Such polynomials are called biquadratic polynomial. Note that 6, 8 and negative 5 are called constant polynomial as their value is fixed. 6. 6 we can write as 6x raised to 0. So here the constant polynomial has degree 0. The constant non-zero polynomial has degree 0. What about the constant polynomial 0? 0 can be written as 0x, 0 x squared, 0 s cubed, 0 x raised to 4. All are 0. 0 into any number is equal to 0. So the constant polynomial 0 is called 0 polynomial whose degree is not defined. But constant non-zero polynomials its degree is fixed. What is the degree of constant non-zero polynomial? That is 0. Next one, exercise 2.1. Which of the following expressions are polynomials in one variable and which are not? State the reason for your answer. For an expression to be a polynomial term, so just remember, for an expression to be a polynomial term, it must contain no square roots of the variable, no fractional or negative powers on the variables, and no variables in the denominators of any fraction. The first one, 4s squared minus 3s plus 7. Which of the following expressions are polynomials in one variable? Here, variable is x. only one variable. So, and here no square roots of variables, no fractional or negative powers on the variables, and no variables in the denominator. So, it is the expression is a polynomial in one variable x because in the expression there is only one variable x and all the indices powers of x are whole numbers. Or second one, y raised to 2 plus root 2. Here only one variable y and the power of y is a whole number. It is not a root, not a fraction or not a negative number. So it is a polynomial in one variable y. This expression is a polynomial in one variable y because in the expression there is only one variable y and all the indices power of y are whole numbers. So it is a this is an expression. This expression is a polynomial in one variable. Now 3 root t plus t root 2. Here root t. So that means variable is a root. So this expression is not a polynomial. So because in this term 3 root t, the exponent power of t is half, which is not a whole number. Next, y plus 2 by y. Here variable is in the denominator. So this expression is not a polynomial because in this term 2 by y, the exponent power of y is negative 1, which is not a whole number. Now x raised to 10 plus y raised to 3 plus t raised to 50. Here all the power is a whole number. Powers are whole numbers. But how many variables? X, y and t. So this expression is not a polynomial in one variable. Not a polynomial in one variable because in the expression three variables x, y and t occur. Now next one, second question. Write the coefficient of s squared in the following. Here 2 plus x squared plus x. This is x squared. What is the coefficient? Numerical part of s squared? It is 1. What is the numerical part of s squared? 1. And here 2 minus s squared plus s cubed. Here the numerical part of s squared is negative 1. So negative 1 is the coefficient of s squared. Next, here x by s squared term is pi by 2 s squared. So the numerical part is other than s squared. What you can see here? Pi by 2. So pi by 2 is the coefficient of x raised to 2. Here root 2 s squared minus 1. So the term with s squared is root 2 s squared. So its coefficient is cut s squared. What is remaining? Root 2. So root 2 is the coefficient of x raised to 2. Next one, give one example of each of the binomial of degree 35 and a monomial of degree 100. Here, degree 35, 3x raised to 35 minus 4. So this is a polynomial with the degree 35. And 8y raised to 100. This is a monomial with the degree 100. You can write many. Only one example I have given here. Many you can write with the monomial of degree 100. 7y raised to 100 or 3x raised to 100. Many you can write with a monomial of degree 100. Now first binomial of degree 35. Binomial of degree 35 means 3x raised to 35 minus y or 7y raised to 35 minus 8. So many polynomial you can write like that. Now next one. Write the degree of each of the polynomials. 5x cubed plus 4x squared plus 7x. What is the degree of this polynomial? Here the power of x is 1, power of x is 2 and power of x is 3. What is the highest power? 3. The term with the highest power of x is equal to 5x cubed. So exponent of x in this term is 3. So the degree of this polynomial is 3. Next one, 4 minus y squared. Here the term with the highest power of y is equal to y squared. The exponent of or power of y in this term is 2. Therefore, the degree of this polynomial is 2. Next one, 5t minus root 7. Term with the highest power of t is 5t. So what is the exponent of t, power of t in this term? 1. So the degree of this polynomial is 1. So 5t means 5t raised to 1. The power of t is 1. So that is the highest power of the variable. So the degree of the polynomial is 1. Now 3. Here 3. Variable is not seen, but it is there. What is that? X raised to 0 or y raised to 0. Any variable raised to 0. So what? Here it is a non-zero constant polynomial. So the degree of this polynomial is 0. Okay. So 3 can be written as 3 is equal to 3x raised to 0 or 3y raised to 0 or 3r raised to 0. Any number raised to 0 is equal to 1. Here the power of that constant polynomial is 0. So in this it is a non-zero constant polynomial. The degree of this polynomial is 0. Now classify the following as linear, quadratic and cubic polynomials. Linear polynomial means a polynomial with the degree 1. Quadratic means a polynomial with the degree 2, and a cubic polynomial means a polynomial with the degree 3. First one, s squared plus x. What is the degree? Highest power is 2. So degree 2 means it is a quadratic polynomial. Here x minus s cubed. The highest power is 3. So highest power is 3 means it's a cubic polynomial. Then y plus y squared plus 4. Highest power is 2. Highest power is 2 means quadratic polynomial. Here 1 plus x. Highest power is x raised to 1. 1. So it is a linear polynomial. 3t, highest power is 1. So it is a linear polynomial. R squared, its power is 2. So it's a quadratic polynomial. 7 is cubed. The power of x is 3. So it's a cubic polynomial. When the degree of the polynomial is 1, it's a linear polynomial. When the degree of the polynomial is 2, it is a quadratic polynomial. And when the degree of the polynomial is 3, it is a cubic polynomial. This will be the end of class 1 of polynomials. So next, so this is, you have to go through this one and learn well, understand well. This is so easy, nothing is there, just what is polynomial, what is algebraic expression, what are polynomials, and what are quadratic polynomial, cubic polynomial, linear polynomial, and what are monomial, binomial, trinomial and all. Only this much, power of the polynomial, coefficient, etc. So nothing else. So next class we will learn more about polynomials.